So I was inspired by this project over Hackaday, which was done by Peter Walsh, where he uses ultrasonic energy to improve the efficiency of ammonia generation. So I thought, why not give it a go and see if I can improve the energy density of lead acid battery. So this is what I come up with. So this is my experiment setup. So let me turn on my lights. Okay. So what you see in front of you right now is this is the Arduino. Controlling the timing and the charge and discharge cycle of this battery, and this is basically just a simple 3D printed battery that I made with my 3D printer. And inside this box you can see there are two lead electrodes. This is the negative electrode and this is the positive electrode, and you can see there's a small bit of lead oxide and lead dioxide being formed near the electrode surface. So basically what this device does is it forms a battery so that it can be used to store energy. So there's nothing fancy about the program. The program just control the timing and control the charge and discharge cycle. And now what you see on the green LED here is just a simple 1 second pulse, and the red LEDs is the charge and discharge indication. So this is cell A and this is cell B, and if it is light up, it means that the battery is currently charging. If it is turned off, then it means that the battery is discharging. So this is battery A, as you can see, and this is battery B, which is inside the ultrasonic cleaner. And this I modified the ultrasonic cleaner to have this lid so that I can have a direct access to these switches, because I need to use my Arduino to control the timing of the cleaner. And this is just a simple relay just to control this ultrasonic transducer. At the moment I turn it off because it is loud for the video, and the display that you're seeing right now is displaying this is the number of seconds that the ultrasonic transducer will turn off, and this is the number of seconds that it will be turned on. And this is the voltage on cell A and cell B. This is the status, charging or discharging, and this is the time taken per charge and discharge cycle. Let me try to focus that, and let me try again. And as you can see, the period on top is much lower than the period at the bottom. So this means that this battery can hold much more energy than this battery. So the time here in millisecond. Wait, let me try to focus this again. I'm not too sure if this will come out on camera, but the time that you're seeing there is just the period between charge and discharge cycle. So in other words, for every charge and discharge cycle, this is the period. This is the period for every charge and discharge cycle. And the circuit over here that you see is just a simple op-amp circuit which generate constant current. So this Arduino is controlling the constant current charge and discharge mode, and that's about it. And the blinking LED on the Arduino is just the loop speed. How fast is the loop working right now? And now the yellow LED that you're seeing there is the ultrasonic transducer status. And now when I turn on the ultrasonic transducer, let me turn it on, and you will see that soon after this timer times out, it will activate the transducer. So I want you to look at the timer. So all the timer does is it just turn on the ultrasonic transducer for 5 seconds for every 30 seconds. So wait for it. Okay, so basically that is just that is the operation. That is how it works. It is quite simple. Now let me just turn it off because it is too loud for me. Okay, so now the interesting observation is that the cell, the battery that is inside the ultrasonic cleaner bath, has a much higher period of charge and discharge cycle. Hopefully you can see that. Probably it is not clear. Yeah, I'm not too sure if you can see that, but basically, according to the period, according to the display, it seems like the battery inside here can hold much more energy than this one. So this probably means that the usage of ultrasonic acoustic energy is able to help the battery to store more energy. I'm not too sure if this is true yet because this is my first experiment, and this experiment been running for 2 days now, and probably I need more time to confirm the effect. But so far, the result seems to be quite positive. It seems like the acoustic energy is able to help the battery to store more energy. I'm not too sure how it works yet. I will try to look at the electrode under microscope later. But for now, the result seems to be quite positive. You might want to look inside the cell one more time. Let me try to get a better view. I'm not too sure about this light. Just saturating my camera. I am unable to get it to stay in focus. But anyways, so you can see that there's a slight bubble near the surface of the electrode. The camera just refused to focus. And on this one, there is no bubble. There is no bubble on near the electrode, and this is probably the reason why the battery can hold more charge. But I'm not too sure yet. But you also might notice that the color of the electrolyte becomes a little bit darker, and this is probably because of the agitation of the electrolyte. Where this one, all of the precipitation stays at the bottom of the cell. I cannot get the camera to focus. Okay. So yeah, and if anything that you're gonna get from this video, that will be, it seems like the usage of ultrasonic acoustic energy able to help the battery to store more energy, almost twice as much, I think. If you can see, if you just can see the number. No, my camera just refused to focus. But yeah, so that is the preliminary result, and yeah, that's all. I think I will try to run this experiment for a few more days just to confirm the result, and if this does work, then I think I will have to try this on a real battery instead of this homemade battery. Oh, and by the way, this is just sulfuric acid, and yeah, that's all, and thank you for watching.